have a quorum?
I think we do. Are we ready to roll, David? All right. We're ready when you are, Mr. Chairman.
I guess the first item is to conduct the comment period for citizen participation. Anybody have any comments? Seeing none, we can move on to item 2, approval of the minutes from our November 21st meeting.
I make a motion to approve the minutes.
All in favor? Aye. Motion passes. The third item is discuss and resolve various transit system traffic engineering operational law enforcement issues. Got any issues we want to talk about?
Nothing on the RTC transit side. Anything from law enforcement today? No. Nope. Okay.
The next item is receive a presentation from Dr. Dean Sicking, PE, University of Alabama at Birmingham, on crash barrier and attenuation system.
Yes, Mr. Chairman. Dr. Sicking gave a presentation, in fact, the identical presentation, I believe, at our bus shelter committee, maybe, what, 2 months ago, maybe, in that range. Mr. Rosen, Rick Rosen here, is on the committee, and I was given a presentation myself to the committee on an unrelated topic, and I saw what Dr. Sicking was talking about, and I said, we need to get this in front of the operations committee, subcommittee, the traffic engineers. Obviously, the RTC has a vested interest, and we are focused on bus stops. The agencies have all done a good job over the last couple of years using RTC money, and in fact, I think in some cases their own money to acquire rights of way and to push the bus shelters and bus stops back away from the traveled way in order to create a little more buffer space. Recently, we know that the county has put in bollards down Las Vegas Boulevard to, protect the pedestrians from errant vehicles. So those two things are related. This system, Dr. Sicking is going to be talking specifically about how they might be used to protect bus stops where you don't have the ability to move the bus stop back because of physical constraints. But it really can be applied in any situation where you're trying to protect, pedestrians, the roadside environment from an excursion of a vehicle. So that's kind of the background, and then after he's done, we can have some conversation on where we go from here. I have some ideas, but I'd like to get your input as well. So if you want to take it away, Doctor?
Thank you very much. Appreciate the opportunity to come speak to you, and hopefully we'll be able to exchange some information. I'll learn something, you'll learn something, and we'll all be better off. Glasses don't work at this distance. So,
Are we picking up recording okay? You might want to maybe talk more directly into the
this being
microphone.
recorded?
Yeah, that's a little better.
Much better. So, I've been working in occupant protection for highways and roadsides for many, many years. Since 1980, developed more roadside safety products than all the rest of the country combined in the last 20 years or so. And so we've been very successful. But one problem we haven't worked on before is, how do I make that play?
Is there an embedded video?
There we go. No audio. Got no audio. But at any rate,
We can get to that, I think.
well, while he's working on that, basically the bus stop is something that's been totally ignored by the roadside and
Maybe we might have it here.
roadway safety community.
Bus stop is now suing the RDC. Conan Obenchen claims in a federal lawsuit, putting shelters only a few feet away from the curb creates a danger to the public. Back in 2012, Obenchen lost his left leg and most of the use of his right leg when he was struck by a vehicle as he sat at the bench. Now, he was just 15 at the time. The RTC spent millions of dollars since 2008 upgrading and moving shelters back where they can.
I guess.
The man who lost his leg at a bus stop is now suing the RTC.
So basically, you get the picture. One of the big problems, well, is that the protecting pedestrians sitting at the bus stop, bus riders, and we really haven't looked at this from a roadside safety aspect, where we're trying to provide protective features to keep traffic from encroaching into bus stops or any roadside pedestrian area. There is really currently no good solution. Bollards are being used, but that will protect the riders. The bus riders will be protected by the bollards, but unfortunately, the bollards can cause great injury to the motorists. So using bollards to protect pedestrians is a poor trade-off, because the pedestrians are there at certain times of the day, and sometimes there are many more, and sometimes there's hardly any. But the bollards are there all the time. Night time, especially when drunk drivers are on the road. So the risk to the motorist is very great, and it's probably not the best solution. But some of the things that need to be considered when you develop a barrier to protect bus stops, in the ADA requirements, you have to be able to allow sufficient space for handicapped people to get around the structures and get into the waiting area and get on the bus. But it also has to be able to protect the drivers of high energy impact vehicles. And so we have to protect the motorists from striking the end of the bollard or the end of the barrier. We have to protect the motorists, the bus stop patron from being struck. So you have to have a system that can absolutely withstand the hardest hit that you're going to expect to incur, as well as not injure the driver. You can see here, many bus stops are like this. You're 4 to 6 feet from the edge of the curb to where the benches are. So any barrier that protects these benches have to be very narrow. And in many cases like this, does this have a pointer on it? I guess not. Many cases like this, there's no place to flare the barrier out of the way. You just basically have to run the barrier along the curb and terminate it, and treat the end so that when vehicles run into the end, it's safe. And so here's one of the options that we're considering. In fact, it's the option we're considering. Can you make that play?
Sure.
It uses a stack of 4-inch wide by 8-inch tall tubes stacked on top of each other. And this is a 45 mile an hour impact with a 5,000 pound pickup truck striking the barrier, and shows that the barrier would provide adequate protection for both the driver as well as the bus stop patrons. And this is the same top view of that same impact. This would be a zero injury case on both the bus stop patrons as well as the driver, occupants of the vehicle. See how the end of this barrier is flared on the left, flared out away from the travelway? If there's a place to tuck the end of that barrier behind a building or another obstacle, then you would do that. Otherwise, you have to come up with an attenuation system to protect motorists from the end of the barrier itself. This is another view of that same impact we just saw. This is how the flare would be implemented. This is a bollard. It's 1 foot embedded 1 foot into the ground, but it can withstand an impact of that we just saw from the pickup truck at 45 miles an hour, 5,000 pounds. And we use a hinge system, as shown here, to allow the barrier to be flared backwards. This is the bollard system that would be embedded underneath that. You can see the simulated impact here is the same truck, 5,000 pound truck striking at 45 miles an hour produced only a minor bend in that tube, so it's got more than adequate strength with only 12-inch embedment. I'm going backwards. How do I go forward?
Can we? Oh,
There we go. So the other options that we want to talk about a little bit is that this also could work for temporary barrier for special events. We've modeled this, and we're quite convinced that we could have up to 400-foot long sections between anchors. So we'd have one anchor every 400 feet. You could deploy the barrier fairly effectively, lay out 25-foot sections of barrier, connect them together by dropping a pin from one to the next, and anchoring them every 400 feet. You could put up a lot of special event barrier in a very short period of time. And it would absolutely protect motorists and pedestrians from high-speed impacts up to 50 miles an hour with a 5,000-pound vehicle. And so it's proposing what we really need out of, what I'd really like to hear from this group is, what is it that you really need? What are the restrictions on both the bus stop and your temporary protection systems? And, you know, the first step in solving any major problem is identifying what the needs are, what the concerns are, and what the limitations are. And if we get some feedback to addressing those issues, it would be a really big help for us. It would help us solve your problems, and we'd both win. Any questions?
As far as the in treatment, the video you showed last time, I think, was you know, how the in treatment collapses and kind of folds out of the way.
Here it is.
Okay.
This is a full-scale test of one of the proposed end treatments. See those pieces of steel coming out? Those are folded and flattened tubular steel elements, and they provide a very controlled energy dissipation rate, and we can guide those things anywhere we want to once we flatten them out.
Because obviously that's a major concern. It's, you know, in a tight urban environment like that, having those rails, you know.
We can even there's one design that actually captures them. They just stay, curls them up inside of a canister, so they don't come up. They just go inside of a circular canister attached to the head, so they don't ever come out. If you'd prefer that, we could do that as well. These are designed to come out so that you could see which way they see how it worked.
Oh, okay. So they wouldn't necessarily have to.
We could guide them wherever you want them to go. Can I get that to play? Can you make that play again?
Sure. I'm sorry. Let's see. Down here. There we go.
There we go. See, those were designed to display out to where we could see them with the camera. We want to see what they look like when they're coming out of the system. But we can do much better at controlling where they go when we have a need. So the two choices would be to guide them down underneath the car that's impacting the terminal, or put them inside of a canister and then curl up inside the canister. Do either one.
Now, of course, if an errant vehicle were to strike the end of the treatment or the end of the barrier rail like that, they're obviously going to be encroaching on the bus stop too. I mean, this really designed more for the crash where it's not coming, it's, how do I, rather than longitudinally down the street where the car is probably already on the sidewalk or close to the sidewalk and hitting the very end of it head on like that, it's really designed for that glancing blow, that 25-degree angle where the car is already through the intersection where there's been a crash, and then the two cars together are going at an angle into that far side stop.
Right.
Is that right?
Basically, I think you have it
Yeah.
right. But go ahead.
Is there any data on what type of secondary crashes?
What type of what?
Secondary crashes would occur after the car is deflected?
See, that's the advantage of an energy absorbing system. We grab the front of the car and we try to hold on to it. And in most cases, we can slow the car down by more than 50%. And in many cases, we can stop it. But we can't capture all of them, but we get most of them.
So that's the idea. So it's not going to be a hard rebound back out into traffic.
No,
It's going to absorb
Most-
energy
most
and
cases-
keep the car on the rail.
keeps the car on the barrier
Right.
and brings it to a safe stop.
I'm sorry.
Go ahead.
The question I have is, the testing here is being done head-on. Have you done testing at an angle?
Yes, we have. In terms of, what I was trying to show here was the basic principle. We don't have an approved system right now. We have done some testing at an angle. It seems to work pretty well. But I'll be the first one to admit we have not conducted compliance testing yet. Compliance testing would be required before we could put it on the market, of course.
So prior to the meeting, Dr. Sicking and Rick met Joe and I out at the track, the Speedway, where it's not the same technology, but it's kind of similar in the concept.
Yeah, it's in the same family of,
The soft barrier rail out of the track, right? You
Safer
were
barrier.
involved in that, in the creation of that?
I led the development of the safer barrier for NASCAR.
The outside,
Yeah,
inside.
both. They're both the same.
Would the barrier be able to handle an impact from a bus?
Yes, depending on the angle and the mass of the bus. So about a 30,000-pound bus, which is a typical city bus, it could handle impact up to about 7 or 8 degrees without a problem. If you want to do more than that, we could accommodate it, but it would just be a little bit stronger barrier. It costs a little more. So that's why we need to know what your needs are. How big of an impact are we going to talk about? So a 30-mile-an-hour impact at 10 or 15 degrees, not a big problem with the bus. 45-mile-an-hour impact at 15 degrees, that's a big problem. So, but we could handle it. Clearly, we're handling race cars going 160, 170 miles an hour. We can accommodate the bus, but it just puts more structure in the system, and it costs more to build it. But again, that's why we're looking for what do you need. We want to design the barrier to meet your needs. Because
How does the system interact with the presence of the curb?
that's the beauty of the vertical barrier. It basically doesn't allow the car to interact with the curb at all, because the steel wall sits right on top of the vertical curb.
So you have the curb, and then you install the barrier up on top of that?
Right on top of that.
So the wheel hitting the curb first doesn't have an impact on how?
The wheel wouldn't hit the first. The wheel hits the face of the barrier first.
So the barrier sticks out from the edge of the curb?
No, if you think about a tire coming into a curb at an angle. The leading part of the tire is the most forward edge of the tire. It's roughly 15 inches off the ground. That's going to be the first contact between the car and the barrier. It's going to be the leading edge of the tire, which is 15 inches off the ground. And it's going to be that steel is going to be basically flush with the face of the curb. So the tire is going to contact the steel first, not the curb.
So,
What's the height of this bollard barrier system?
Right now, it's 40 inches. We reduce it or increase it as needed.
So the system that you've tested at 45 miles an hour for a 5,000-pound vehicle, what's the penetration that you observe?
Well, it depends on the system. The one for a bus stop would be about 6 to 8 inches. A flexure in the steel barrier, that'd be it. But if we want to do the temporary one, which is 400 feet long, you have deflections up to almost 3 feet.
What would change in the design if you went for a 15,000-pound vehicle?
We'd probably just put more steel in it, make the tubes a little bit bigger, be about the same. It would be, the design would be very similar, just upgrade the depth of the tube from 4 inches to 6 inches. Probably be enough.
So if you were to look at doing this on a bus stop, you would be looking at far more right-of-way with that additional steel.
Well, yeah, that's one of my questions, is, how much room is there? What we saw out of the track today, were those like 6-inch tubes?
8.
Those are 8.
Yeah.
So,
So we're talking about a barrier that, as currently envisioned, is 4 inches wide and has a flexure of up to 6 or 8 inches during normal bus stop installation. And why would you need multiple right of way?
well, because there's got to be, what, 4 feet between the back of the barrier and the front of the bus shelter, right?
But the
Clear.
steel system of the bollard itself will be longer.
It doesn't move.
If
Mm.
you're looking at a 15,000-pound vehicle with a penetration of less than a foot with the barrier system, you're looking at anywhere from 7 to 9 feet of steel I-beams
In the ground?
in the
Over
ground.
the anchoring system?
No, for this bollard system, then the fascia of the barrier that goes down, the beams that you're looking at, they're pretty,
Well, they're also, where's the curb? If these are on the curb, this is sticking out.
this is centered.
This is the shaded part is pavement, so everything else is under the pavement. The only thing that's sticking up is the bollard.
I think what would help us, if we're looking at this going forward, is what this would look like underneath our typical roadway section, like where the placement of the crossbars are and the placement of the bollards in relation to the sidewalk, the curb and gutter, and the typical bus shelter placement. The locations where we have concerns are where we already have some right-of-way challenges. So you have a 5-foot curb or 5-foot sidewalk and then a bus shelter immediately behind it if you're lucky to have that kind of space. And so our concern is how you fit a system between the bus shelter and the curb and still maintain the ADA.
So this is exactly what I'm looking for. Is, what size of vehicle and impact conditions do you want to accommodate? What your space limitations requirements are? And what do you need to see? And what are you looking for optimally solving the problem? What will be your nirvana? And then we'll get as close as we can to it. That's all we're asking for.
Yeah, and I don't know if you were here when I mentioned it, the background. Dr. Sicking brought this to the Bus Shelter Committee, and I was there for another reason, and I saw it and I said, oh my gosh, we need to get this in front of the traffic engineers just so you know that this technology is out there. Then talking to Mr. Rosen and Dr. Sicking, out of the track today, that's exactly what they're looking for. What are the physical constraints that would have to be designed for to move this forward? So, this is really just kind of an FYI at this point, let you know that it's out there. I know that we have, like I said, the county has been putting the bollards, down Las Vegas Boulevard. Bollards are probably not the best solution in front of a bus stop. Maybe they are, I don't know. But what are those parameters that you would then take back to the laboratory and draw up and come back with something that would fit? Because that's really the key.
Right.
There's just the physically constrained environment just doesn't leave room for anything more than like 6 inches.
Well, I think the most important one I would be looking for is the penetration. What is going to be your penetration at impact?
So how far does that wall deflect into that space?
How far the vehicle passes the barrier into the sidewalk?
The vehicle doesn't pass the barrier in sight.
Well, depending on the vehicle type. If you got a car, you got the barrier at 40 inches, probably not. But if you got a semi,
Well, yeah, if you
got all the
now you're
Sure.
if you want to require this barrier to stop a semi
Yeah.
at any reasonable speed, say 40 miles an hour, it just there's nothing can accommodate that. Even the most robust bollards can't accommodate that. But so hopefully your limitations will be within the realm of feasible.
right. And I think that's why I mentioned the 15,000-pound vehicle. It's not a WB50 or 62.
Was that the design vehicle for your bollards?
Right.
On this-
So that's basically your 29-foot U-Haul truck.
Yeah, that's what these bollards were designed to stop. It was the
The
50 mile an hour.
penetration is the
So how close, so the vehicle hits the barrier deflects, the vehicle deflects into the space that you're trying to protect? That's what you mean by penetration distance? And is that close, how close is that to the thing you're trying to protect? In this case, the bus stop.
Right. In our case, we have 15, 20-foot sidewalks. The penetration, the best you can do is 3 feet,
1 meter.
1 meter. If you go, that's a P1. If you go to a P2, it can go up to 20 feet. So you're shooting for P1. But in our case, I think for bus stops, when you got a 5-foot sidewalk, 3 feet is almost
So,
defeating the purpose.
but that, either the same impact on the 50 mile an hour, 15,000 pound truck, that the bollard has to stop. This barrier, because we've run that barrier upstream of the impact zone, well upstream of the bus stop, he doesn't have to stop that truck. He just has to steer it out of the way. And he can do that much easier and much more effectively than the bollards, and with deflections on the order of less than a foot.
Right, but when you look at the flared end,
Well,
build this flared end section that you're showing in your example.
That was one example. The other one is a straight design. It would extend upstream just straight, and it would not be flared at all. So you might have to extend it upstream maybe 50 feet or so to keep vehicles from running behind there. But I assure you, this can accommodate the high energy impacts at least as well or better than the bollards without taking up space. Because it doesn't have to stop the truck. You just need to steer it out of the way. Much less energy needed to be absorbed, much less strength required to deliver to the system. But again, tell us what your parameters are, and we'll see what we can do about hitting your targets.
Can you go back to the one that shows the truck?
This one?
Yeah, so where would the bus stop be in relationship to this?
Sorry about that.
That's a real good question, is where I'm going.
Time's up.
So in this case, right, that's it, it's exactly right, where the hand
And
is.
this flared end in our environment is not practical, because there's just not enough room for that. So what's going to happen is you're going to have some sort of attenuator, some sort of in treatment here.
Right, it would extend the barrier further out and then put the end treatment further upstream. Yeah, right there.
And the
That's
load's way up there.
And the bus
stops way over there.
So is it conceivable that, because that was one of the things Joe and I were talking about on the way back, is that, if the bus stop, how do people actually get in and out of the bus behind this barrier? So obviously if the bus stop is in here, you can't have people come up and around and into the bus this way. Because now there's obviously a pinch point. So if the bus stop is down here and these things are upstream of the bus stop, now the loading zone is out here somewhere, right?
Could be.
So I don't know how you can protect the whole face of the bus stop and still have enough room to load and unload. I'm sorry, Gene.
Well,
One thing I kind of like about it is that this could be used, you could continue with fencing to discourage people from jaywalking. It would make pedestrians go to the corner. You'd have a steel block there, for impact when they're sitting there, but the rest of it, with the attenuator, then the rest of it would be just regular pedestrian fencing to the corner at those locations where we have that issue.
Yeah, because the people sometimes like to come out around the front of the bus, and then they get hit, as people go past the bus stop, rather than coming out, turning, and coming back. Because most of our bus stops are far side
Right.
in the valley. So the major intersection is back here, upstream of the bus stop. So yeah, that's true. Any kind of pedestrian containment, because we have a serious problem with pedestrians getting hit jaywalking from bus stops. I didn't think of that, but I think that's a good point.
I think another consideration with that kind of system is driveways and site visibility.
Yeah. If they're
Yeah.
crossing further,
Yeah, if there's
That
a
would
driveway
be-
down here,
yeah,
can the person exiting the driveway see
right.
past this thing? So what's the site zone, 30 inches? You can't have anything above
24 is what our code says, but
24 from top of curb? So 30 from
But-
the floor?
Well, the bollards are taller than that, right?
Right, but it's not a solid fence.
But it could be
It,
one.
it becomes effectively one at the low profile angle, low perspective angles.
So do you have any examples of could you, I guess that's what you need, so if we were to come back and say, okay, we've got to have at least 4 feet between the back of the rail itself and the front of the bus shelter, we can't allow more than a foot of penetration into that clear zone, or safety zone, let's call it, and it can't be any higher than 30 inches or 24 inches from the top of the curb. Those are the types of things you need
Yes,
to go
That's
back
what we
and
need.
say, this is doable or not.
exactly.
I believe the object height is 36 inches for roadway design visibility.
24 seems short.
Pardon me?
24 seems short, but, go ahead.
Curious, during a rain event, if the barrier is flush with the curb, does it allow for drainage?
It'll be on top of the curb.
Be on top of the curb.
So there'll be a gap?
Yes, small gaps underneath it.
So for sheet flow off the sidewalk into the
Yeah.
curb under the barrier.
So it won't be like a bathtub for the bus?
Won't be collecting water.
Okay, good question.
And sometimes the
But I'm still,
Yeah, go ahead, Joe.
well, I'm still curious on how we're getting the people protected onto the bus.
Yeah. So yeah, can you explain that?
So basically, the concept is that there'd be the actual loading zone would be 2-3 feet beyond the end of the barrier.
Down here somewhere.
Right, so when they're loading, they would be exposed to traffic, but when they're waiting, they're not.
Well, they're basically protected by the bus being in there.
Right, when they're loading, they should be protected by the
So,
bus.
okay, so the shelter is here, behind the barrier, but then the bus stop is gonna be up here, so they're gonna go up and around the barrier and get on the bus stop up here.
Exactly, that's the plan.
Understood. Okay.
So the stop is just basically north of the shelter.
Exactly.
How many events can this barrier sustain? Is it a one-time only?
Oh, no, if you, again, it is what you make of it. If you tell me you gotta withstand an impact of a 15,000 pound truck at 15 degrees, we can make that a completely repeatable event. You hit it as many times as you want. Or we can make it so it's damaged during those impacts, but withstands, say, a pickup truck at 50 miles an hour, 15 degrees, as many times as you want. So we can accommodate what you want. We just need to know what it is. It is what you want to make of it.
So the county you've had your thinking caps on this issue, developing the spec for the bollards. So, again, like I said, this is just to make you folks aware of it, the traffic engineers aware of it in the valley. I think we can come up with some general concerns, physically how this thing fits, talk to the county on their spec for, penetration, design vehicle, et cetera.
Sidelines.
Sight lines, yeah, sight distance. I can be the clearinghouse for that information and get it to Dr. Sicking.
That'd be great. That'd be a really big help.
Yeah, I can only say this, that in our research and in talking to all bollard companies, nobody has done any testing of impact at any angle other than head-on.
Well, you're talking to the wrong companies. Bollards are only hit head-on by bollard companies.
The testing hasn't been done, so if
Based on your research for developing the spec for the bollards.
Well, and I think we need to remember that the bollards that we're talking about that the county is installing is for a different purpose too.
Yeah.
So, the outcome, the result of that can be different, I guess,
Mhm.
one way to say it.
It's a somewhat different application.
Yes.
Right.
I think a much different application. So I would really like to see, moving forward, once we have some of these parameters established, what a schematic of this would look like installed into our existing infrastructure.
Yes.
And that could be one of your requests. These are the parameters we'd like to accommodate. Well, if we designed a barrier that met those criteria, what would its footprint look like? That's what you're asking for, right? That'd be, we could give you that, no problem. Obviously, it'd take us a while. We'd have to go back and rerun this modeling and redesign some of the elements, but we can certainly do that.
So assuming, okay, we're taking a giant leap of faith here, assuming that, it could come up with a design that fit, that met the specifications, this is, do you see any reason why it wouldn't be considered in your jurisdictions for, some other reason, aesthetics or, I know that's hard to quantify, but are there any inherent barriers to the concept if we could get the specific details ironed out? Or is this just, dead on arrival?
I think the maintenance issue would come up.
Your question, how many times can you hit it?
Well, and also just maintaining curb and gutter and what
Yeah.
does it take to,
And if the landscaping rock piles up against it on the other side, and now you've obscured the sidewalk, do we have to sweep the sidewalk a whole bunch more?
Got it,
Graffiti issue.
Graffiti?
yeah,
That's,
okay. Well, like I said, people running into bus stops doesn't happen very often, but it does happen. And it's a tragedy when it does. Obviously, the bollards on the strip, that's to prevent an intentional attack.
But they're
These
there
are
all-
meant for accidental intrusions, so it is a much different problem to solve for. But in my mind, I don't see any inherent problems with putting it out there if we can get it to fit and we can get it to do what we want. I think no stone should be overturned, because I do it myself. You're driving down the road at 45, 50 miles an hour, and you got people sitting literally for hours, I won't say that, several minutes, waiting for the next bus, at least 15 in some cases. So they're exposed, so what can we do to protect them? I think it's a fair question.
Just leave you with a little thought. I spent 20 years as director of the Midwest Roadside Safety Facility. We were one of the certified test houses for evaluating anti-ram barrier systems, including bollards. Bollards are not a safety feature. They're not put there with the intention of considering the life of the driver. And so I'll leave you with that.
Right. And in an application where you're trying to prevent an attack, that's perfectly appropriate. When you're on an urban arterial and some person, rider, as wrong as it is distracted momentarily and goes off the road, we don't necessarily want to knock that person
Or
out.
a kid runs out in front of him, he swerves to avoid the kid, and,
Great example.
yeah.
didn't hear what he said.
If a kid or somebody runs out in front of them and they have to swerve around the obstacle, unexpected obstacle, and they, boom, oh my God, we're in a bus stop. And, 4 or 5 people are lost because of some crazy accident. So anyway, I will get the crew together. I'll talk to them individually. I'll put together a list of some of those parameters, high-level stuff, and get it to you. Obviously, I don't think you'd have a problem with any of the committee members contacted you directly with.
Oh, I'd love it. That'd be fabulous. I'll leave you some of my cards.
Okay.
That'd be great.
So I'll be the clearinghouse for the information, but feel free to interact on your own.
Thank you very much.
Thank you.
okay. The next item is discuss topics of interest.
Yes, Mr. Chairman, I have one. In the last cone management meeting, one of the goals of the cone management group is to review the conditions of approval, the processes at the agencies for pulling temporary traffic control permits, and to find where there might be opportunities for consistency amongst the agencies, not only in conditions of approval, as I said, but also process. So moving forward to accomplishing that goal, what we have done the RTC, Chris in particular, has went through, pulled down all of the conditions of approval for each of the agencies. We now have NDOTs too. And we have a list that, obviously this wasn't agendized, so I'm not going to be handing anything out, but I will get it to you after the meeting. All those conditions of approval that are common to all agencies. And there's 30 of them. A word or here might be slightly different, but they are essentially the same thing, accomplished in the same thing in the same way. 30 individual conditions of approval. Then each agency has anywhere from 1 or 2 to maybe a dozen, call them supplemental conditions that go on to where conditions that are unique to the permitting agency. Let's put it that way. And again, as I explained in the Cone Management Group, the goal is not to make a single set of conditions of approval and to handcuff the agencies. What we want to do is a review to see what are the commonalities, where can those be consolidated, which conditions are accomplishing a specific task that's common, which conditions were one-offs at one point to address a particular thing that may not exist anymore. And the simple, as we all know, sometimes the simple thing to do to cover our you-know-whats is to put a condition on them. Recognizing, however, that each agency is unique political pressures, unique built environments where a single set of conditions on a temporary traffic control permit are probably not in the cards or even really desirable. But we've been tasked with kind of reviewing, consolidating where we can, and then turning something back around for industry's comment. So initially, the idea was that we would get a working group together, a subgroup of the cone management folks, basically your barricade inspectors. We can still do that because they are probably the most knowledgeable as far as the real-world ramifications and the real-world application of the rules. But after thinking about it, I think that this is probably something that this subcommittee should address from a formal perspective. So we can actually have a formal industry review period. So what I'd like to do is get your opinion on the role of this committee in reviewing how the Valley processes and temporary traffic control permits. What is the role of the traffic engineers in this process? What do you think? I know I was long-winded like usual, but it's important. Comments, thoughts? Are we barking up the wrong tree, or is this something you guys want to be involved in?
What's the goal? I mean, I know you want to
Mhm.
make sure we're all
Well,
being
ultimately, the
consistent.
goal is to, that's a great question. Ultimately, the goal is, bottom line, simple, speed up the process. Make it simpler, make it, speed up the process of not only getting the barricade permit, but ultimately in getting the cones off the road. So any place where we can streamline, any place where we can consolidate, any place where we can simplify, generally leads to gains in efficiency. One of the things that we're hearing from industry, both the utilities and the barricade companies, is that each agency's rules are so different and processes are so different that it is really difficult to know what they're going to get when they go in for a permit. Now, I was on that side of the table, so I know that that's greatly exaggerated. But I think there's some element of truth to that. You can't manage what you don't measure. So my goal at this point, back to this, is just to get it on paper. What are everybody's conditions of approval? What is the process? Now that it's on paper, we can look at it objectively and say, what do we want to change? What can we make better? What has to stay? And what's there just because it was a leftover from how they did things 20 years ago? Let's get rid of those things. And then I can think we can go to industry and say, okay, this is it. What's your opinion? What can be improved from your perspective? Ultimately, with the goal of speeding things up.
So I think you said two things there. That first you mentioned the conditions of approval, which I think we're all going to have to approve any changes to those anyway.
Right.
I mean, regardless of whether you bring it to this group, we wouldn't attach it to our permits unless we approved it anyway.
Absolutely.
So this is sort of, not that I mean this in a negative way, but approval by this body would sort of be a formality.
Mhm.
So my question related to that would be, would you anticipate that going into some sort of standard blue book format or something like
Mhm.
that? And then secondarily, you mentioned process.
Right.
So every entity is going to have a different process, and there's a lot of reasons for that. Structure, IT support, the type of software tools that we're using, the ability to pay with credit cards or not, the ability to submit electronically or not. So what do you see the RTC's role as being in our processes, in process improvement? Are you trying to review it from an outside party, or?
Well, right now, the goal is limited to getting it on paper, and with not, the RTC, to be blunt, has no role in your internal process as far as how you want to send somebody through City Hall to pull a permit. But the RTC does have a role to the extent that it's a regional issue, and on projects of regional significance that we fund, I think that since that's a key component of project delivery, the RTC has a role at least in being involved in documenting what those processes are and putting that in a place that everybody can review and look at and chime in on.
So if they're already documented, it could be as simple as just attaching a link?
Yeah.
Has there been any thought given to looking at the specifications? Because there are some things in the specs that are sort of universal that nobody's doing.
Absolutely.
For instance, full-size scaled plans of barricade submittals prior to starting work, or prior to the kickoff meeting. I mean,
Right,
that doesn't happen.
exactly.
I
Yes,
was going to
it-
say, I've never seen that in 10 years.
It's in the specs, but nobody does that.
right.
I
Exactly.
don't think the barricade companies are equipped to do that either.
No, absolutely not.
So, that might be a place to emphasize focus, on cleaning those up. And there's redundant language in there too, there's redundant language in multiple locations.
Absolutely. One of the things that Chris is doing is he's going through all the 600 series drawings and putting them in the modern CAD format. Again, working through the Cone Management Committee, or the Cone Management Working Group, the idea was, again, to review, they were published 20 years ago. Literally 1997 was when those drawings came out. And the spirit of the things is these are typicals that could be referenced on an RTC-funded project. But every barricade permit is unique, so but it doesn't necessarily have to be unique. I mean, we could require a barricade plan. We could go down the path that NDOT has, in an RTC project, we'll have a maintenance of traffic plan, a barricade plan that's a part of the plan set. We don't want to do that, but that is one possibility. Your point is well taken. The specs are not great when it comes to temporary traffic control. So starting with the drawings and to get those things up to snuff was really where we were going to tackle that. As far as your comment on, the role of this committee, absolutely, it's really, you were going to be involved one way or the other, because those people answer to you, whether it's in a closed-door working group environment or whether it's in a public setting like this. The reason I thought that I owed you the professional courtesy of bringing it up here is that because this is an open forum, we have the opportunity to hear from industry and the public, and the transparency of the conversations and getting what the individual agencies' real concerns are on the record, I think helps build the case on why it is the way it is. It's rather than, just people making up rules behind closed doors. This forum gives it a sense of legitimacy and transparency that doesn't happen behind closed But one way or the other, ultimately, you're not going to say approved by the city of Henderson until you are satisfied with the conditions. And the RTC, again, doesn't really have a role beyond, a formal role beyond the specifications, which have to be cleaned up.
So I think your point is well taken, and I think it would be helpful that in your co-management group, as you work to consolidate or make a standardized list of typical conditions, that, you know, you have the industry partners involved there, and then when you do present it to this group, then they specifically speak up and say that, you know, they were involved in the development of this and are okay with these conditions. I mean, at least then we have that concurrence on record.
Yeah, on the record that all the stakeholders had a voice in this thing, and I think that's powerful. So what I'm hearing is,
So,
Go ahead.
I'd like to make a comment.
please.
At the county, we have the development side that has their own encroachment permit and traffic control plan.
Mhm,
Then we have the capital side.
mhm.
I would be hesitant to have RTC require traffic control plans be a part of the project requirements that have been funded, because now you're getting into the realm of means and methods, which might end up costing us more than what we bid.
And you're not the only one. So the point is that through the specs aren't going to change without concurrence from this group, the spec committee, ultimately EAC. You know, so the specs are a collaborative effort, for sure. But there are many different ways to skin the cat. And that's why we don't want to go down the path where we are dictating that. We want to make sure, we like the system the way it is, but I think we owe industry and the public a top-down review.
Right, and just to continue that thought is, I would like to see it in two different groups. One is the development side, and then one is the capital side. I don't hear too much on traffic control issues from our capital side. I don't see many issues,
Mhm.
you know. But it leaves, our specs are written such that, and we modify them, where it leaves a good dialogue with the contractor to facilitate changes after you bid the contract to accommodate his special equipment for use and so on. So on the capital side, it seems to me it's working great for the county. I don't know much on the development side. So when you listed the 30 common conditions, I don't believe we put a lot of conditions on our traffic control from the capital side. And I may be
Right, well, you rely on the specifications for that.
right. And it's really.
And the
based-
special.
Right.
Yeah.
It's based on the means and methods state, and we try and control the number of lanes they take out. So that's our control. So if you come back, I'd like to see the separation, because I think the development side of encroachment permits, barricades is where we may be having, there may be issues, or we need to have consistency maybe.
Okay, I get it. You want to add something, Joe? Well, it looked like you were getting ready to.
No.
Okay. Okay, so to summarize, we are going to send, just so you have it, we're going to give you what we gave the Cone Management Group, just to get it directly. We will continue to reach out to the Cone Management folks, your folks, with this initial effort to get everything on paper. We're talking to industry. We're going to have a meeting with some of the ATSA representatives just to get their perspective on these things. A subcommittee of the Cone Management Group will be convened. We'll get this stuff on paper, and that's going to be a few weeks out for sure. Then we can, we're going to, again, this is going to include, a review of the specifications. The drawings have already started. Then we will maybe huddle up and to see if we should bring, if there should be a formal submission to this group. I'm hearing that you wouldn't oppose that, right?
No.
Is there any reason not to bring it to this committee once we're at that point?
I would have hesitation on making suggestions on the county's development barricade and traffic control process. Me.
Okay. Well, that's fair.
I would also add that, as you mentioned, NDOT has a fundamentally different process.
Mhm.
So it would be challenging to meet concurrence, I would imagine.
Right. Because you do require,
Because we do require additional items
right,
that are likely not to change.
right. Right, and I think it might be fair to say that maybe very few of these things are likely to change, but, you know, there's utility in looking at it, I think. And, you know, 30 conditions of approval that you all agree on for a temporary traffic control plan, I mean, just on the surface, that seems a little much.
Is there a reason you're not wanting to clean up the specs and drawings first before we talk about conditions of approval? Because,
Well, no, not really, other than, I mean, we've started. It's just that in the Cone Management Group, it's been talked about, and they were kind of, okay, when are we going to get started on this? So we start there. And this is really more probably on the development side, like Kaizad was saying.
oh,
So, excuse me, I got one more little sip here. Got it. So that's my key to shut up, so. So more to come. We're going to be working with your barricade people, and then we'll come back to you folks.
okay.
So that was all I had for topics of interest.
I have a topic that I would just like as a reminder. I'm looking still for a explanation as to why we have no rebar in the streetlight foundation.
Yes, and we have the answer to that.
Oh, awesome.
It's not required. Jacobs, we had Jacobs Structurals look at it. They went through both the building codes that apply. I have the whole backup, the whole file. I can bring it. Now, was that a formal request to the committee? Is there an outstanding item that we need to bring back to this committee? Or was that just you asking me afterwards? We can review the record. It wouldn't hurt to bring it through this committee.
You can bring it to the committee. In the meantime, you can send me what you have, because I have a structural engineer
Asking questions.
through the building department
Yeah.
asking, I'm
Thanks,
perplexed why we don't have rebar in a 4-foot foundation.
Yeah. Not
PennDOT has it in their 5-foot streetlight foundation, but
Is it roadside? With-
I'm.
Thank you for reminding me.
Yeah, you're welcome. So thank you for getting that taken care of. I
Yeah.
appreciate it. Okay, anybody else have any topics of discussion? So next item is conduct a comment period for citizen participation. Seeing that we have no citizens here, I think we're good. With that,
We have a lot of citizens.
Dr.
meeting is
Sicking
adjourned.
left me his card, so anybody who would like one of his cards.